All right, welcome everyone. So next up we have Scott Triglia. He's tech lead at Yelp, and the talk is called Arrested Development. Please welcome him.
All right, thank you all for coming out. So I'm going to be talking today about my team, the product we build, and sort of how we bought into the excitement, the promise, and maybe a little bit of hype surrounding microservices. So we're going to talk about lessons we learned in the first couple years of working with that, and after the shiny coat of new paint wears off an idea, what are you left with, and how can you make sure you're building a robust application? So I want to start out with a brief background on the company, make sure we're all on the same page. Yelp, if you don't know, is essentially an app, or if you're feeling old-fashioned, a website, for discovering local businesses near you. So we're looking to make sure that you can find that great place to have lunch, or that place to go shopping, or somewhere to get your shoes repaired, wherever you're at. And we have a fair amount of content as well. So we have about 80 million reviews on the same order of monthly unique users, and a lot of diversity in the businesses we support. So often people will associate Yelp with restaurants in particular, and that is a very popular use case, but we actually have more shopping businesses than restaurants and a very long tail of a variety of different categories. A little bit about me. As I said, I'm Scott. If you are inclined towards Twitter, you can find me at Scott Triglia on there. And I've been with Yelp for about 4 years, working primarily in back-end systems, a lot of time on the search team there, and a little bit of machine learning in my spare time. So I've worked a lot with our service stack, a little bit of contributing towards it, and quite a bit as a user, as a developer. And I want to describe my team as well, the product we build, which is called Yelp Transaction Platform. You may catch me referring to it as just platform. This is the same thing. And in short, our goal is to make sure that when you're using Yelp, when you're searching for maybe dinner in Brisbane, and you want to find some awesome businesses, as much as possible, we want you to actually be able to transact with those businesses on Yelp. So if you're in San Francisco, for instance, and you search for delivery around dinner time, you might see a variety of start order options within your results. And if you click on one of those, we want to take you into, for food, a menu experience. So if you click on Nick's Crispy Tacos in this example, you're going to hopefully see some crispy tacos that you can go ahead and purchase. As I mentioned, though, we're not just restaurants, so we also make available a variety of other verticals, other types of products, shopping for clothing, or maybe booking a hotel room. And we do these through a variety of external partners that we partner with. And regardless of what it is that you're purchasing, we're looking to bring that whole shopping experience to a conclusion on the same app or the same website. So that's a little bit about my team and what we build. I want to make sure that we're all on the same page as well, though, about the concept of microservices. A quick show of hands, who in this room feels familiar with what a microservice is or what the concept means? Oh, pretty good. OK, so we'll move through this relatively quickly. It's obviously a very popular term. It came up maybe in the last couple years prominently. And I'm partial to Martin Fowler's description, not just because he's sort of one of the people that came up with this idea. He describes it as so, and I won't read it out loud to you, but I want to just pick out a couple parts of it, a couple points he makes. He talks about microservices being a suite of small services, so we're talking about more than one service, more than one server, and hopefully not letting them get too large. He also focuses on them being in their own processes and using lightweight mechanisms to communicate. So we're talking about isolated services not running within a single web app. And by contrast, you'll often hear the term monolith brought up in these discussions. And a monolith, in short, is essentially just the opposite end of the spectrum. If microservices are a lot of small independent pieces talking together, a monolith is one big web app doing all of it inside of itself. Think Django if you want an example of this. And this is sort of the default mode. You'll often hear people disparaging monoliths or talking how they're outdated and a poor design choice. I want to be really clear, although this is not the focus of my talk, that isn't always the case. When somebody tells you about their monolith or describes a monolith they're building, just ask how large it is. Get a sense of what scale you're talking about. In Yelp's case, we're talking millions of lines of Python code for our monolith. So when we say big, we mean big, right? This isn't a single Django app that I can write down in 5 or 6 modules. This is an enormous block of code. We're dealing with hundreds of developers simultaneously developing on it. And there are very good reasons at that scale to move away from the monolith. If you're interested in how to decide whether you should or shouldn't stick with your monolith, Martin Fowler also has a really good article called Monolith First that kind of gets at that design choice. But for us, we decided this was no good. And I want to just briefly justify that decision so you get a sense of where we're coming from. First off, our monolithic Python code really resisted decoupling, aggressively resisted decoupling. And I think this is something that it's hard to emphasize how hard it was. I'm sure you're thinking to yourself, well, no, Scott, I can think of at least 5 ways to decouple Python code bases, right? There's SOAP interfaces, there's a lot of different tools you can employ here, maybe ABC, abstract base classes. And we thought all those same things, and we spent probably easily 6 months, a lot of developer time, saying, we can do this, we can split up our monolith successfully. And we basically found that while it might technically be possible, it was a terrible ROI for our developers in general. So again, 1.2 million lines of code, hundreds of developers, decoupling was really impractical. In addition, it had a bad habit of catering to the lowest common denominator. So when you get in a code base this large and this old, Yelp had, I don't know, roughly a decade of development behind it, you find that there were some choices that made sense at some point in the past that don't make sense anymore. And getting away from those choices, no matter how obvious the migration need is, can be really, really challenging. We started before Python had stable web frameworks, and so we wrote our own, right? And 10 years down the line, no matter how much you might want to migrate off it, it's a very expensive proposition to do so. And finally, and this was kind of the kicker for us, monolithic code was just really slow to deploy. When you have to push all of 1.2 million lines of code together anytime you change any part of it, when you have to test the entirety of your repo anytime you change part of it, turns out it's really a pain and your deployment process starts to suffer. And we weren't interested in deploying more slowly, so that left us with breaking up the monolith. So we did so. This is a highly sanitized graph of the total cumulative number of services over time, right? And you can see that basically from when we started this, roughly when I joined Yelp 4 years ago, this started off pretty strongly and hasn't looked back since. So this graph kind of represents the glory days of the monolith to services transition. It doesn't get better than this. This is the point where you're going to see those first well-defined services get split out. You're going to see deployment times speed up. You're going to see testing become easier. All of a sudden, you actually have interfaces between code in the form of your APIs. And this is really a glorious period of time, kind of the honeymoon period. But this is something that you're mostly going to hear about when you hear people discussing microservices. This is the nice story, right? This is the ideal situation, the happy path. And you might know that this is not what my talk today is about, right? I'm not here to tell you how awesome microservices are. I'm here to tell you what happens after you've bought into this and you do it for a couple of years. And a funny thing happened, because when we started out initially, we had this really idealized view of microservices, an idealized view of how good it was going to be as we got away from the monolith. And for the most part, we saw that borne out. Particularly in the first year, it was awesome. We got faster deploys, we got isolated systems, and basically it was what we were told. And we felt like we had a good picture in our heads, and what we had created matched that exactly. But a funny thing kind of happened maybe a couple years in, is we looked back. We looked back at that picture we had in our heads and what we thought we were getting out of it. And we realized that what we'd actually built, what came out, and what we were looking at 2 years in after we had scaled up, it wasn't quite what we had in mind, right? It had a lot of similarities. You could, in fact, trace it back and see where, in some parts, we were still getting benefits. But the architecture wasn't there. It wasn't feeling stable, and we weren't feeling like we could really get all the benefits we had been promised. So what are a couple of reasons for that, right? What were we seeing that was hurting us so much? First off, our API complexity increased significantly due to organic growth, due to things like needing to version our API. When you start out, you have a pretty good image in your head, hopefully, of what your service is going to do and what purpose it serves. And as you grow over time, that image kind of gets a little fuzzier, maybe, right? You end up patching in some last-minute fixes because a product has to go out. Or you end up changing maybe a year into your service what the core purpose of the service is. And as a result, the API complexity just grows. It's sort of inescapable. And that makes a lot of other things a lot more difficult. We saw our interactions really get very murky. Knowing what happened when I called into a service used to be really simple, right? The service did one thing and it did it well. And we found that after a while, as those services got more complicated, knowing what was going to occur when I called a service, when I posted to an endpoint, became correspondingly more difficult. And when you have your application as a network of these service calls all interacting together, knowing what's actually going to happen is really important and very difficult. And finally, the process just wasn't scaling. We were hoping that we were going to find faster deployment, that we were going to have new developers be able to ramp up very quickly on a project because it was all these well-conceived services. And we found that after we kept scaling up on this process for a couple years, none of those things were holding true as much as we would like. So what can we do about this, right? We're left in this spot. We've bought into microservices a couple years ago, and we're finding that a lot of the benefits have actually gone away. This thing isn't scaling as well as we were told. How can we attack these problems? So today, I'm going to just talk about two main areas, mostly in the interest of time. There's a whole suite of things that could be discussed here, but I find these two to be very important. And so we're going to dive into them a little bit, explain what we saw that was going wrong and how we can fix it. And the first one of those that I'd like to talk about is essentially defining these services, keeping a consistent definition of what a service is and what it does, and how we can continue doing that as we grow a larger and larger application. And the first point that I'd like to make here is coming from our Python monolith, strong interfaces were really rare, right? And this is sort of arguably a Python feature, problem. Is that it's very difficult for us to maintain in a large code base interfaces that are well-defined. We actually know what they claim to do, and that are following that interface. That not only do they claim to do something, but they really do something, both the definition of an interface and the validation of it. And you might be familiar with code like this. Arguably, this is actually kind of nice code, right? It's a fairly major interface in our system. We're going ahead and taking a user's order that they've created, and we want to charge their credit card and maybe tell them about it after the fact. So this is not something we want to get wrong. And we often see code like this in a monolith, right? It's very nice. It's Pythonic. You see a snake case. You see a little usage of language features like kwargs. But if we dig into it a little bit, we can discover that it's not actually an awesome interface for us to understand what's going on. These arguments into the function have nice names. I can guess what they do. But as far as what they actually are, Python doesn't really give me any hints. And in fact, it allows me to be very lazy if I so desire. So what is an order? That's a fairly important concept. I certainly can't tell it by reading this function. What are those kwargs? Well, somebody decided to use a nice language feature to pack up a bunch of keyword arguments. But again, just looking at it, I have no idea what those are. Do I need to send any? Are they entirely optional? Tough to say. And this validation that we're doing down here, what can we really say about what is or is not happening there? Hopefully it's doing what it claims. What if it's put in there sort of optimistically by a developer and it actually just has a pass inside the function? It's very, very tough to make strong guarantees, right? And I won't say that we had anything quite that bad, but I will say that partially validating things is a terrifying, terrifying result. So we tackle all these problems in the system, in the context of microservices with a tool called Swagger. You might have heard earlier yesterday Andrew Stewart talking a little bit about using it with the Falcon web framework. And for us, we use it within our own system, and we use it for three main purposes. We want to first really document services. This is for developers. Make sure we know what a service does. Make sure we know how you interface with it and why you would ever call that particular endpoint. We also want to make clients smarter programmatically. So we're looking to take as much of the busy work and the sort of mechanical nonsense of writing an HTTP call and automate it away where possible. And we also want to make our servers smarter. So anything that we can do on the server that will be benefited by having a strongly defined API, we're looking to get better about that. So let's look at what this actually means. If I'm a developer and I want to use Swagger, what do I have to do? Well, the good news and maybe the bad news is you only have to do one thing, but that one thing is fairly tricky, surprisingly tricky. In essence, you have to write down a formal spec for your entire API for your service. And when I say formal spec, I really mean it. You're going to have to go through, and for every endpoint, you're going to need to define all the different parameters that come into that endpoint. You're going to need to write down their types. You're going to need to write down, are they optional or not? And you need to iterate this process through your entire service. This might not sound awful. You know, theoretically, we all know our services. We know our APIs. But I can tell you in practice, it's astonishingly painful. You can take your best developer, You can, sit her down and say, please write this entire spec, and you kind of cross your fingers and hope it'll go quickly. It doesn't. It's painful, and odds are you don't know your own API. On the upside, this is a very good kind of pain because you don't know the API you're working with. And this should be setting off red flags in your head that if you don't know something so important, you can't hope to make smart decisions to make automation based on it. So the only thing developers have to do is write the spec. As a result, they get a few benefits. I talked about documentation. So Swagger has a pretty rich ecosystem of tooling, and one of the cool things it offers is something called Swagger UI. So this is essentially an interactive browser for your system. You write that spec, and it will be reflected here. So you can see here an example from their sort of default example spec. And you'll get to see all the different resources. You'll get to see the gets and the posts, maybe the deletes. If you have any doc strings, effectively, summary information about the endpoint, you can see it there. And you can actually do some nice interactive querying of a backing service. So this is sort of the I want to learn about a service, I want to know what a particular endpoint does documentation solution. And you get this for free once you write that spec. On the client side, we're interested in, again, automating as much of the mechanics as we can. So Yelp has an open source library called Bravado on our GitHub. And Bravado's goal is to go ahead and basically take down that Swagger spec from a service that it's looking to talk to, learn about the interface it's attempting to call into, and do as much of the automation and the mechanics as we can for you. So first, it offers an auto-generated client. You can do things like client.pet for the pet resource, and it learns about that when it pulls down that spec from the remote service. It does local validation, so if you are horribly miscalling a particular function, like maybe we send a pet ID of foobar, then it will yell at you before it makes a network call. Kind of a nice feature. And it also pulls in things like help from the Swagger schema. You basically get as much as you can from that spec, and you automatically integrate it into the client. One thing it doesn't do is it doesn't attempt to paper over the fact that you're doing an HTTP call. We sort of made some early attempts in this direction, and we discovered that all of the convenience of pretending you weren't going over a network was really a time bomb in practice. And you're much better off just admitting to the fact that you're making an HTTP call and letting Bravado do a lot of the mechanics for you, like constructing the right URI. On the server side, we also have a solution. So I have a library called Pyramid Swagger that hooks into the Pyramid web framework in particular. There are other options if you prefer something like Flask. And essentially, we're doing the same process. We want to say, I have a spec for my service. Please hook it in. In this case, it's very simple. You just put it in a predefined place and include the library. And then what you're going to get out is all of the benefit of doing that. So this is built-in serving of the spec, so clients can go ahead and ask you for your whole Swagger spec. This is going to be request and response validation, so you can go ahead and automatically make sure your service is actually adhering to that spec that you set out, and a variety of other goodies. So essentially, we're just trying to, again, reduce the opportunity for mistakes and lighten the load for making new services and new endpoints. OK, so what can we draw as lessons from all this discussion? First off, your interfaces in services really need to be intentional. It's not enough to go ahead and write a service one time. You have to keep making sure that it stays consistent and coherent and means something. And this is something that's very easy when you first design these services and very hard to maintain over time. And nothing suffices except to just keep reading the system that you have and making sure that it's a coherent interface to the outside world. In addition, you have to be explicit. So you really need to make sure that you're not being accidental about what your interface is. Make sure you've written it down somewhere. Having an interface defined as essentially the sum total of your entire server is very confusing and offers you no ability to do anything intelligent based on that data. So writing it down in Swagger gives us hard data that we can use, share elsewhere, and ideally, we can use it to automate a lot of the overhead. And this is the big downside of services. Essentially, by breaking it out of the monolith, you've created a ton of overhead for yourself anytime you want to change something or make a brand new service. So you really have to very aggressively make sure that you're keeping up to date, that you're automating everything that's mechanical, and that'll let you scale up to larger and larger systems. OK, so that's a lot of talk about how we basically understand the systems we're working with, how we make sure we do that when we first write them, and how we make sure we keep doing that as they grow larger and larger. But just understanding the systems sort of as they stand conceptually isn't really enough. And one of the big pain points we discovered was that as we grew the system larger, we used to be able to just understand what was going to happen from first principles. But very quickly, we realized that what was going to happen from first principles and what happened in practice were maybe entirely different things. And so this concept of understanding what's happening in production is actually quite separate from understanding your system in theory. And that kind of leads us to something like this. So we got a bug report from one of our customers, one of our partners, and they informed us that, hey, we're seeing some 504s talking to a particular API that we maintain, user info API. So how do we debug something like this, right? It's a kind of vague bug report, and it's happening in production, and that's kind of all we're given. In ancient times, kind of back in the bad days, we might have used an approach like this. You might take your most senior developer, stick them in a room, covered floor to ceiling with whiteboards, and hand them all the logs that you happen to have available, right? Just whatever's lying around because you kind of didn't think about this ahead of time, and say, please debug this obscure production issue. And my kind of strange analogy here is that it's kind of like being told to do a research project and all of your resources are just someone's random bookshelf, right? It might be relevant. If you're really lucky, it's exactly what you need. But just picking up old logs that someone happened to leave lying around is not a very professional way to debug what's happening in a complex system. OK. So we don't want to take any random logs lying around. Let's do a step better. Let's say we have a bunch of services. We're going to write logs for them, right? We like logging. So we're going to log all the incoming requests. We're going to log any data that we might need about those. And we're going to go with that approach so that we don't have this random collection of logs as our source of data. Unfortunately, this presents a new problem, right? We no longer have to worry about not having the data, and we now have to worry about drowning in a sea of it. And sending out your on-call engineer and saying, please debug this problem in production, here is like the Library of Congress, good luck, is, again, technically OK. Maybe they'll make do. Maybe they're really good with grep and awk and tools like this. But we can do better than that. And so what we've kind of settled on is essentially the combination of really detailed logs, obnoxiously detailed logs, you might say, and some excellent tooling for looking into them and examining them. And for us, that's been Elasticsearch and Kibana. And you might often hear about them in concert with this little guy, Logstash. And collectively, this is the ELK Stack. If the term ELK Stack is kind of strange to you or you don't know what I'm talking about, I'd really encourage you to see Honza's talk later today on sort of best practices for logging. And I believe he's going to be talking about this very subject. But what I'm going to talk about is sort of how we use it. So Elasticsearch is just a data store. We're going to take all the logs we have and stuff them in that data store. And then we're going to be able to flexibly query it because Elasticsearch is a really cool search engine. And we're going to get pretty Kibana dashboards because Kibana makes things pretty. So the funny thing happens when you do this is that you immediately learn things that you never had a chance of knowing before you did this. This is a very simple dashboard where we're just basically graphing every partner request we get, and we're breaking it down by who's sending it, right? Because we have a number of external partners. And before we did this, we sort of, quite naively, assumed that everyone had a pretty regular calling pattern. There wasn't anybody doing anything too strange. And of course, we discovered the moment we graphed it here that, wow, there's crazy stuff happening here, stuff we never knew was going to happen, patterns we didn't know existed. So how does this help us with that mystery 504? Back to our original question. Well, it turns out that we can build very, very specific queries into Elasticsearch, into Kibana, rather. So we can ask for very specific data. In this case, we can say, just give me all the results with a particular pyramid method name, so all the things that are coming from the user info API, and just toss out anything that had a 200 status response, right? Leave me all the stuff that's left over. And we can look at how often those occur over time. And sure enough, we see our single spike that corresponds to that 504 that was reported by the partner. And we can dive straight into exactly what the problem is and discover more about the solution. And the really nice thing, once you stack up this much data in one place and make sure it's comprehensive and it's available in a rich tool, is you'll learn really surprising things. So actually, what we ended up finding out under the hood was that this 504 was being caused because timings were 10 times worse in one of our data centers. And we didn't know this. We had no way to know this except to log all the data and then give ourselves a tool for really diving in and examining it. And realistically, we'd love to not require our customers to tell us this stuff in the first place. It's a little inefficient, and it's hard to guarantee that we'll get all the data. So we use a tool called ElastAlert, also on our GitHub, that essentially does flexible alerting within Elasticsearch. So you have to tell it three main things. You have to tell it what you want to look at, in our case, a particular Elasticsearch host and index. You have to tell it what you're looking for. So we might say we're looking for at least 20 events within 2 minutes, a spike of events of some sort. And you have to tell it what you want to do if you see that. So in our case, most of the alerting we do says, look for something like a spike of errors, and if that occurs, please page somebody, send an email, do something alarming so that we're aware of this problem. And this closes that loop, that feedback loop between all that data that we now gather and being able to actually know about important things when they happen. All right, so let's draw some lessons. First off, logging is a superpower. I would tell you that you should use it wisely, but I don't want to give the wrong impression. You need to be using it constantly. And this is true in a monolith, but it becomes even more essential in this array of microservices because the complexity of the system that you're working in has increased. And that raw data by itself is not enough. You need to also visualize it, and if you're doing anything even vaguely mission critical or customer facing, you should probably be monitoring on it as well. And these approaches together make a world of difference. We took our system from an incident response that might take days to realize something went wrong. You have to wait for an email from one of your customers, down to minutes. We were getting alerted immediately. And the investigations into what went wrong might never have been solved before because we just simply didn't know what was going on. And now we have a strong tool that we could go ahead and dive in and answer the questions that we have. OK, so let's kind of wrap up a little bit and draw some overall lessons. The first one, no surprise to a room full of people familiar with Python, is we need to be explicit, okay? The first step is getting away from sort of an implicit world where you interact with a service that doesn't really know what it does. You interact with an interface that isn't clearly stated anywhere, and start being very clear and very explicit about the systems we're working with. And if you start out with this explicitness, then you actually have somewhere to go forward from and make smart decisions on. And the next step after doing that is you have to measure everything. Again, if you don't know what's happening in production, you can't, as a human, hope to make wise engineering decisions, much less make automated decisions. So things like logging, things like knowing where your errors are happening, making those available in machine-readable formats, very important. And lastly, and this is kind of our solution overall to this microservices problem, is you have to scale with automation. Microservices inherently are putting a lot of overhead into your system. They're making things that used to be pretty easy much harder, and hopefully you're getting some good organizational benefits out of that. Unfortunately, you can't use the old approaches you used to use. You have to sort of change with the times, spot the places where that overhead can be minimized, and automate it all the way until it's essentially gone or close to it. All right, I want to leave you with a few resources. I talked about some code repositories. So Bravado and Pyramid Swagger are both Swagger-oriented, the client and the server. And ElastAlert is that monitoring framework on top of Elasticsearch. And these are all available on GitHub. If you're interested in this overall question of how you go from a monolith to services, there's a very good long-form blog post by sort of our tech lead of the services team describing what we did, how we did it, and lessons that we learned there. And if you're interested in something a little more bite-sized, we have sort of some service principles for designing brand new services, how you can do that in a way that you won't immediately regret a year later. And with that, happy to take any questions. If you don't get a chance to ask me, feel free to catch up with me on Twitter or email or out in the halls. Thank you very much.
Thanks a lot. It was really good. I liked how you kind of covered a bit of a dev and then an ops story. Just wondered if you could touch maybe on the software development life cycle you've got where you might have multiple services in development that either consume or provide to each other, and how you manage that between the teams.
Sure. Yeah, that definitely is a complexity. I think we aim as much as possible for the development lifecycle to let them be completely independent of each other. That has a lot of really good upsides in terms of being able to deploy your code without worrying about everyone else. We talked earlier about what happens when you have hundreds of developers that all need to worry about everybody else deploying their code simultaneously. But it also comes with challenges. There are testing challenges there. There are sort of making sure that the deploys don't step on each other challenges. It's very complicated. If it's not a simple thing to describe, but if you want to talk after, I'd be happy to get into more detail with you.
Hi, Scott. I was just wondering, when you guys initially transitioned to using microservices, if you noticed when you had the monolith, if you were calling an API to be the cost of a function call. When you go to a microservice, you're introducing the cost of either IPC or network traffic. I was just wondering if you noticed a performance cost, and also, particularly when you've got the network there, if you noticed a reliability cost as well.
Yeah, no, both great questions. I will say we use Python at Yelp. 95% of our code is built in Python, so performance costs are something that we are familiar with, right? We're already not choosing the most performant language we could. So when we switched over to services, we definitely saw a bit of a hit. I think the most extreme hit in performance is kind of what I alluded to earlier with doing stupid things cross data center accidentally. That's a killer. That'll easily cost you seconds that you don't know about. As far as reliability, I think that's actually the more important of the two issues because it hits you everywhere. Hits you in production, it hits you maybe most nasty in testing, when all of your tests that used to pass all the time because they're correct start failing 10% of the time, not because they're incorrect, but because you have all these sources of failure involved. Yeah, very challenging and something that we're still working through.
Hi. Many of the sort of lessons you talked about in the first half, you talk have a lot of correlation to normal coding practices around making sure documentation's there and explicit. And just wondering, are there any specific differences between, say, documenting a specific code base versus a microservices-based project?
Sure, any differences in documentation? I think one thing that we definitely noticed was it's easy to be lazy in a single monolith because, strictly speaking, you'll be told immediately if you're wrong. Or at least you'll be told more immediately if you're wrong, right? If you do something truly awful, you're going to get yelled at the moment you call a function. In general, just the space for mistakes is smaller when you're in a single code base. And so while none of the fundamental issues went away in that scenario, they were much less apparent and much less damaging when they went wrong. So there's that. And then I would also just say the nice thing about APIs is you can actually conceive of something like Swagger that exhaustively documents the entirety of an HTTP API, which is possible in something like Python, but I think we do less often as programmers. Yeah.
All right, I'm afraid that's all we have time for, but thank you very much, Scott.
All right.